Welcome back to Simply Sports Science for everything you need for IB Sports Science and GCSE PE. When we watch sport, it's easy to assume that the conditions don't matter much. A run is a run, a throw is a throw, or a kick is a kick. But in reality, the environment changes performance all the time because it changes the external forces acting on objects. And in biomechanics, that's a really big deal because once an object has been released, whether it's a ball, a javelin, a shuttlecock, even a swimmer's body moving through water, its motion is shaped by the forces acting upon it from the outside. So today we're going to look at this key idea, that environmental conditions such as temperature, humidity, air pressure, wind, salinity of water, and altitude all affect the external forces acting on objects. In simple terms, the environment changes things like lift, drag, and buoyancy, which then change how an object moves. So external forces are forces acting on an object from outside the object. In sport, the big ones are gravity, which pulls objects downwards, drag, which can be air resistance or water resistance, which opposes motion through a fluid, lift, an upwards force created by pressure differences in a fluid, and buoyancy, which is an upwards force in water caused by displacement of fluid. Air and water are both examples of a fluid in physics. Air is a gas, water is a liquid, but both can apply drag and other forces. A key point here in the real world, most projectiles don't move through a vacuum. They move through air, which means drag is always present, and sometimes lift is present too. So now let's look at how different environmental conditions change these forces. Temperature. Temperature affects the density of air. Here's the simple rule to remember. Warm air is less dense, cold air is more dense. When air is more dense, it creates more drag. That drag slows objects down more quickly and reduces how far they travel. So in warmer conditions, drag is usually lower, and objects like balls or javelins can often travel further. In colder conditions, drag is higher and objects may not travel as far. And this matters in sports like football, golf, athletics throwing events, and cycling. Then there's humidity. Humidity is the amount of water vapour in the air. This one often surprises students. Even though humid air feels heavy, it's usually slightly less dense than dry air. That means higher humidity can slightly reduce drag. The effect is usually small, but in sports science we really care about small differences, especially in events where distance, speed or flight really matters. Then there's air pressure. Air pressure is closely linked to air density. Higher air pressure usually means denser air, which increases drag, whilst lower air pressure usually means less dense air, which reduces drag. So changes in air pressure can affect how much resistance an object experiences as it moves through the air. Then we'll look at wind. Wind is one of the most important environmental factors because it can dramatically change external forces. What really matters here is the object's speed relative to the air, not just its speed over the ground. There are three main wind situations. A headwind increases drag because the object is moving into the wind. This usually slows the object down more quickly and reduces distance. A tailwind reduces drag because the air is moving in the same direction as the object. This allows the object to travel further. That's why tailwinds can help sprinters and long-distance kicks. And a crosswind blows from the side. This affects accuracy and can cause sideways movement. Crosswinds are particularly difficult to deal with in sports like football, rugby kicking, golf, cricket, and tennis. Then there is altitude. Altitude has a big effect on air density. At higher altitude, air pressure is lower, air density is lower, and drag is lower. Because drag is reduced, objects can often travel further at altitude, and this can be seen in throwing events, long kicks in rugby, and even cycling when they're taking place at venues that are at high altitude. The key point here is about the object. Less dense air means less drag acting on it. Now let's move into water environments. Salinity refers to how much salt is dissolved in water. More salty water is more dense, and when water density increases, buoyancy increases. Buoyancy is the upwards force that acts on an object when it displaces water. That's why it's easier to float in the sea than in a swimming pool. Increased buoyancy can help the body sit higher in the water, which can reduce resistance and affect performance in swimming and water sports. And this all really matters to us as sports scientists and performers in sport, because environmental conditions don't directly change the athlete's movement once an object has been released. Instead, they change the properties of the fluid, air or water, and that changes the external forces acting on that object. When drag, lift or buoyancy change, the object's speed, distance, path or accuracy all change too. That's why a ball can travel further, dip more, curve more or slow down faster depending on the conditions, even if the athlete uses exactly the same technique. Environmental conditions such as temperature, humidity, air pressure, wind, altitude and salinity of water affect the external forces acting on an object. They do this mainly by changing air or water density, which changes lift, drag and buoyancy. And once those forces change, the movement of the object changes too. That's why understanding environmental conditions is such an important part of biomechanics in sport. Thanks for watching Simply Sports Science. If you found this helpful, make sure you like the video, subscribe to the channel and hit the bell so you don't miss any of our IB Sports Science